So I was telling you that you're not supposed to write down the definition of oxidation and reduction in terms of increase in charge or decrease in charge, okay? Because this is not a part of syllabus. Basically, it helps you a lot in, you can say, identifying the process oxidation or reduction in, you can say, in topical past papers they would be doing just after that. But before going into that, I was telling you that you are supposed to find out the charge. And before finding out the charge, you must know some important points. The first point is that the charge for single free element is zero. The charge for single element or free element is zero. I mean to say that this is the single element, free element. Magnesium, sodium, calcium, Cl2, Br2, I2, N2, O2, F2, H2. These are the free elements, like you can say diatomic molecules as well. So their charge is zero. Remember, always remember their charge is zero. Always remember their charge is zero. Okay, this is very important. Always remember their charge is zero. Okay, and then what you need to do basically, okay, you need to know the charge for group 1 elements, that is always +1, and the charge for group 2 elements, that is always +2. Okay, mostly the charge of oxygen is -2. Mostly the charge of oxygen is -2. Mostly the charge of hydrogen is +1, and mostly the charge for group 1 is +1. Not mostly, but always the charge is +1, and for group 2 the charge is +2. Okay, and any free element is equal to what? Zero charge. So this is important. You need to write it down. Let's discuss some questions so that we can apply all the definitions of oxidation and reduction. Okay, so let's have some questions. Let's suppose we have this question. Okay, sulfur reacts with oxygen to form sulfur dioxide. Okay, so we have to determine what is oxidized and what is reduced in each reaction, and also identify oxidizing agent and reducing agent. Later on we would be discussing what is mean by the term agent, but so far we are supposed to tell which one is oxidized and which one is reduced. If you can see over here, this is single sulfur, this is sulfur, and over here sulfur is combined with oxygen. As I told you, the definition of oxidation is an addition of oxygen. If you remember, as I told you, the definition of oxidation is the addition of oxygen, right? Is the addition of oxygen. So since the sulfur is going to add oxygen, so I can say that the sulfur is oxidized. I can say that the sulfur is oxidized. Why the sulfur is oxidized? So you can say that the sulfur is gaining oxygen. This is the reason I can say that the sulfur is oxidized. What about oxygen? Sometimes it's difficult to tell the reduction. Sometimes it is difficult to tell the reduction. Remember, like if I ask, obviously this is oxidized, so ultimately this would be reduced. But how can you tell me that the oxygen is reduced? Can anyone tell me? Can anyone tell me that how the oxygen gets reduced? Yes, any idea? I told you that the sulfur is oxidized because sulfur has gained oxygen, so addition of oxygen is oxidation. But how can you say that the oxygen is reduced? Yes.
By losing its electrons.
Loss of electron is oxidation, not reduction. Reduction is the gain of electron, remember. Okay.
Oh yeah, sorry. Gain of electrons.
The charge for oxygen over here, I told you that all diatomic elements have zero charge. H2, N2, O2, F2, Cl2, Br2, all diatomic elements have zero charge. So this is zero. So this is zero. This is zero. This is zero. Now you need to find what is the charge on oxygen over here. What is the charge on oxygen over here? Okay. So I told you mostly the charge of oxygen is -2 in the compounds, okay, like H2O, SO2, CO2, okay. So mostly the charge is -2. The charge for oxygen is -2. Remember, so obviously this is -2. Okay, this is -2. So it's changing from 0 to -2. It's changing from 0 to -2. Obviously this is the decrease in charge. This is the decrease in charge, and also I can say that this is the gain of electron. I can say that this is the gain of electron. Okay, this is the gain of electron. When this is the gain of electron, ultimately I can say that the oxygen gets reduced. Oxygen gets reduced. Okay, so this was the question that they were asking, which one is oxidized and which one is reduced. So in short, sulfur is oxidized and oxygen is reduced. Are you all getting my point? Yes or no? We would be doing more and more questions to have an idea, to have a grip on this topic. Like, then how would we can tell that the something is oxidized or reduced? Okay, but so far right now sulfur is oxidized and oxygen is reduced. What's the reason? Because sulfur has gained oxygen, since the definition of oxidation is the addition of oxygen. So that's why I can say that sulfur is oxidized, and the charge for oxygen is going to reduce. You can say that this is the decrease in charge. Ultimately, you can say that this is the gain of electron, because it's changing from 0 to -2. If you remember, when we were discussing chemical bonding, then I told you sodium is going to lose its electron to the chlorine. And then if you remember, chlorine had -1 charge and sodium had +1 charge. Why the chlorine is having -1 charge? So you can say that the chlorine has gained 1 electron from the sodium. That's why this becomes Cl minus. So it means that when something gains electron, it means that when something gains electron, so they would be having a negative charge. So this is a negative charge. It means that oxygen has gained 2 electrons, and the gain of electron is reduction. So that's why I can say that oxygen is reduced. I can say that the any doubt, any query? Adan, Madarka, Aryan, Fatma, Mohaimin, Reni, everything is correct. Yes or no?
Yes, one.
Yes, sir.
Yes. Okay. Now see this. Let's suppose we have this. You can see this. This is the second question. Can anyone tell me which one is reduced and which one is oxidized in this equation? I'm giving you only 1 minute. You are saying that lithium is oxidized and sulfur is reduced. But why? How can you tell me that the lithium is oxidized? How can you tell me? Mm-hmm. Yes.
Oxidation state changes from 0 to +2.
This is 0. Why? Because this is a single element. I told you this is a free element. It's 0. The charge of a single element is 0. And also the charge for the sulfur is also 0, right? And if you see this, lithium is in group 1. Lithium is in group 1, so this is +1. Lithium is in group 1, so this is +1. Okay. Lithium is in group 1, so this is +1. So you have two lithiums. Do you have two lithiums? So I can say that this is +2. obviously there is no charge on this compound. This is Li2S. Remember, this is neutral. This is neutral. This is neutral. You know, uh, this is a general question why atom is neutral. So you generally say that atom contains same amount of electron and proton. So that's why they cancel each other. As a result, atom has no charge. Atom is neutral. So this compound is also neutral. Since we know the charge for lithium, that is +2. So this is +2. I know the charge. I want to know the charge of sulfur to make it 0. Since the compound has 0 charge. So you will say that X is equal to -2. Ultimately, this is the charge for sulfur. They would be cancelling each other. As a result, I can say that there is no charge on lithium sulfide. So ultimately, the lithium is changing from 0 to +2 and sulfur is changing from 0 to -2. So 0 to +2 means this is increase in charge. And increase in charge is oxidation. And sulfur is changing from 0 to -2. This is the decrease in charge. And you know the decrease in charge is, you can say it's reduction. Decrease in charge is reduction. Okay? Decrease in charge is reduction. Are you getting my point? Yes? Yes or no? Hello?
Yes.
Okay, good. So in this way, you can tell which species is reduced and which is oxidized. Okay, so this is important. And then see the third question. See the third question, which is oxidized and which is reduced. So basically, this is cesium, this is 0, and Br2 is 0. Cesium is in group 1. So this is +1. And bromine is in group 7. So this is -1. So this is changing from 0 to +1, which means this is oxidized. And this is changing from 0 to -1. This is the decrease in charge. So you can say that this is the reduction. Okay. So cesium is oxidized and Br is reduced. In this way, you can tell which one is oxidation and which one is reduction. Okay. Equation 5. See this question. Fast. So Fatma, you are saying that iron is oxidized and oxygen is reduced. Am I right?
Yeah.
I also agree that oxygen is being reduced and iron is being oxidized.
Since the charge for iron is 0 and this over here, the charge for oxygen is -2 and this is 0. I told you in the beginning that the free elements are having 0 charge. Whether you have diatomic molecules, whether you have different elements, they have a 0 charge. Okay. So iron is changing from 0 to, I don't know what's the charge of iron over here, but let me tell you, let me give you some idea that how you would be finding out the charge. So basically, you know, Fe2O3 is the neutral one. Fe2O3 is the neutral one. Since you know the charge for oxygen, I told you in the beginning that oxygen is always -2. And you know, iron is a transition element. It has a variable charges. Sometimes they are +2, sometimes they are +3, sometimes they are +7, sometimes they are +3, sometimes they are +6. So it depends, basically. It depends. Since we know the charge for oxygen that is -2 over here, you have 3 oxygens. So this is -6. Overall charge is 0. So to make it 0, what am I supposed to write over here? So you will say, sir, it would be +3. Why? Because 3 into 2 would be +6. So +6 minus 6 would be equal to 0. So this is the reason the iron is +3. And in short, I can say that this is a proper, you can say, reason. But in short, you can just find out the charge by just looking at these numbers. This 3 is the charge of iron and this 2 is the charge for oxygen. It's very simple. So I can say that the iron is changing from 0 to +3. I can say that the iron is changing from 0 to +3 and oxygen is changing from 0 to -2. So 0 to +3 means what? 0 to +3 means what? The number is going to decrease or increase. You will say, sir, this is increasing. Why? Because you are going upward, like 0, then +1, then +2, then +3. The number is increasing. So when the number is increasing, obviously I can say that the increase in charge is oxidation. So ultimately I can say that the iron is oxidized. Ultimately I can say that the iron is oxidized as this is changing from 0 to +3. And O2 is reduced. Oxygen is reduced. Why? Because it's changing from 0 to -2. So 0 to -2 means you are going downward, like below 0. This is below 0. Below 0 means what? First is 0, then -1, then -2. So the number is going to decrease. When the number is going to decrease, ultimately I can say that this is what? This is reduction. This is what? This is reduction. Okay. Okay. Now see this. What what do you think regarding this question? Cl2 plus 2 NMBr. Yes. What do you think? Yes. This is a good question. Yes, yes, yes. Yes, yes, yes. Basically, this is 0. Okay, this is 0. And this is in group 1, so this is +1. This is in group 7, so this is -1. This is in group 1, so this is +1. This is in group 7, so this is -1. And this is in group 7, so, oh, sorry, this is a 3 element. I told you that all the diatomic molecules have 0 charge. So this is 0, okay? So it's changing from 0 to -1. It's changing from -1 to 0, okay? Okay, why you are not going to consider the sodium? So I would tell you the sodium is +1 in charge. Has to consider the sodium. So I can tell that I'm going to solve this question, okay, over here. Chlorine is changing from 0 to -1, and bromine is changing from -1 to 0. -1 to 0. So ultimately, I'm going to tell you that chlorine is reduced, okay, and sodium bromide is oxidized. And in sodium bromide, basically the bromide is oxidized. In sodium bromide, basically the Br is oxidized. I'm supposed to tell you Cl2 is the oxidized species. No, it's gaining electron, sorry. Cl2 is the reduced species, and Br minus is an oxidized species. Okay, are you getting my point? Yes, is that clear for all of you? Are you getting my point? Yes or no?
Sir, can you repeat? I don't understand this
Yes.
part.
Okay. Basically, I'm telling you that this is Cl2, this is the free element, this is the diatomic one, this is 0. I told you all the diatomics are 0, whether it's H2, O2, N2, Cl2, Br2, I2, AT2, they all are 0. Okay, this is 0. It's changing from 0 to -1. How can you tell that this Cl is -1? You know, Cl is in group 7. All the group 7 elements are having -1 charge. Or else you can say that sodium is always +1 because this is in group 1. Sodium is always +1 because this is in group 1. Okay, those elements which are in group 1, they are always +1. Always +1. Always +1. So, you know, since the compound is neutral, Since the compound is neutral, to make it zero, what should be the charge on chlorine? You will say -1. So +1 and -1, they would be cancelling each other to make this compound neutral. Okay, that's why this Cl is -1. So the Cl is changing from 0 to -1. So the Cl is changing from 0 to -1. Obviously, when something is changing from 0 to -1, so I can say that, this is reduced because this is a gain of electron. This is the gain of electron. What? This is the gain of electron, and the gain of electron is reduction. That's why I wrote that the chlorine is reduced. Are you getting my point? Yes, we're asking. Is that clear for you?
Yes, sir. Yes,
Okay,
thank
then
you.
on the other hand, if you talk about bromide, Br minus, obviously it's changing from Br -1 to 0. So -1 to 0 means that -1 to 0 means that this is the loss of electron. This is the decrease in charge. You know, -1 is the smaller than 0. -1 is smaller than 0. So when something is changing from -1 to 0, obviously I can say that the charge is going to increase. So, you know, increase in charge is oxidation. That's why I have written the Br minus is oxidized. Okay. Can you tell me this? Question number 9. Can you tell me this? Question number 9, but fast. But fast. Fast, 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 fast. Fast, 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 fast. Sorry. I cannot hear you. What are you saying? What are you saying? Hello, can you hear me? Can you hear me? Yes or no? Hello. Can you all hear me? Amaya, Naika, Aryan,
MG
Fatima.
loses electrons.
Yes, Mg loses electron, obviously, but Mg is
It
changing
loses
from
2.
0 to +2 since magnesium is in group 2. Since magnesium is in group 2.
Yeah, I said
so
that.
you are okay. Since magnesium is in group 2, so that's why this is +2. Something is changing from 0 to +2. Ultimately, this is the increase in charge. So increase in charge is oxidation. So I can say that magnesium is oxidized. Magnesium is oxidized. But why? Because the magnesium has changed from 0 to +2. So this is the loss of electron. This is what? The loss of electron. So loss of electron is oxidation. Okay. And then if you see, this is H. I told you H is +1. Okay. To make this compound 0, obviously this is neutral. So ultimately the chlorine should be -1. Okay, and over here, if you can see, this is 0 because this is the free. Okay, I told you the free molecules are 0, and this chlorine is -1 over here. Ultimately, there are 2 chlorines. Okay, each chlorine is -1. So overall, the charge for magnesium is +2. So you have 2 chlorines. Each chlorine is -1. So the overall charge for the MgCl2 would be 0. So -1 and -1. I'm not considering this chlorine because they are having the same charge. I'm going to consider the hydrogen. Since you know that in HCl, the hydrogen is +1. In HCl, the hydrogen is +1. But over here, if you can see this is H2. This is H2. This is H2. This is the diatomic one molecule, the free molecule. This is 0. So it's changing from +1 to 0. Obviously, this is the decrease in charge. Ultimately, this is the decrease in charge. Ultimately, this is the gain of electron. Okay. So, okay. So I can say that this is reduced. So H plus is reduced. So H plus is reduced. Okay, H plus is reduced. Mg is oxidized and H plus is reduced. Yes, this is the last question. Yes, can you tell me this, but fast? Which species is oxidized and which species is reduced? Yes. Fast.
Sir, can I answer?
Yes.
Sir, at the start of the equation, sodium is 0
Nice. Okay. Then
because it is an elemental alone.
good.
And in 2H2O, the ion of H is +1,
Okay.
and for oxygen, it is -2.
Exactly. Nice.
So after the equation,
Hmm.
we lose one hydrogen atom.
Hmm.
So
So
we can say that hydrogen is reduced
sodium. Remember,
and
sodium is
is
always +1. Sodium is always +1. Okay. Because this is in group 1. Sodium is always +1. Sodium is always +1. And this is 0. This is what? This is 0. As you can see, this is changing from 0 to +1. Sodium is changing from 0 to +1. Sodium is changing from 0 to +1. Amaya, can you tell me this is the decrease in number or the increase in number? Yes, Anaya, can you tell me, but fast, please? We are short of time. Yes, it's the decrease in number. Sorry, 0 to +1 is the increase in number or decrease in number?
Increase.
Good. So increase in number is what? Oxidation or reduction?
Oxidation.
Good. So sodium is oxidized and oxygen is changing from, no, sorry, hydrogen is changing from +1 to 0. Hydrogen is changing from +1 to 0. So ultimately, I can say that this is reduction. This is the decrease in number. This is the decrease in charge. So ultimately, I would be telling you that H plus is reduced. H plus is what? Reduced. Okay. Means water is reduced. Means water is reduced basically. So these are the important equations that you would be solving, and in that equations you would be calculating which species is going to be oxidized and which species is going to be reduced basically. Are you all having any issue, any query related to this? Please feel free to ask. Then we would be moving on to oxidizing agent and the reducing agent. Then you will suffer. If you are not going to discuss this, then you will suffer a lot, trust me. So you must know, you must be good at oxidation and reduction. You must be good at oxidation and reduction.
Can
Then
you solve
inshallah we
one
would
more?
be okay. Let's suppose if you can see this, HNO3 and HI. We have to decide, is this reduced or oxidized, or is this reduced or oxidized? Now this is very clear. This hydrogen is +1. Obviously, to make it 0, iodine should be -1. But over here, the iodine is 0. First of all, tell me, are you getting this point? Yes or no? Is that clear? Is that clear for you? बता दिए भाई क्या हो गया? Okay, good हो गया. चलो जी. It means that the iodide minus I minus is oxidized. If you ask why, sir, so I would be telling you that this is changing from -1 to 0. This is the increase in charge. It's changing from negative to 0. It's increase in charge. Increase in charge is oxidation. Increase in charge is oxidation. Okay, so you have decided the oxidized species. You have decided the oxidized species. Now you are going to decide which species is reduced. Ultimately, obviously, you know that HNO3 would be reduced, but you have to prove. But you have to tell, you have to do a working basically. Remember, if you have decided the first species that is oxidized, ultimately the another species would be reduced 110%. But you need to show the working. Examiner would be having your working basically. So in this compound, H is +1 and O is -2. I told you, I am again telling you that frequently I would be telling you in future as well this, that the charge for H is +1 and the charge for oxygen is -2 mostly. So if the oxygen is -2 and if the hydrogen is +1, if the oxygen is -2 and the hydrogen is +1, ultimately in this compound you have 3 oxygens. In this compound you have 3 oxygens. So it would be -6. It would be -6. So -6 and +1. -6 and +1. It is -5. -6 and +1. This is -5. -6 and +1. This is -5. Since the compound is neutral, since there is no charge on the compound, so what should be the charge on nitrogen? What should be the charge on nitrogen? Adan, can you tell me this? What should be the charge on nitrogen? Adan, can you tell me this, please? But fast. We are short of time. Please, fast. Adan, what should be the charge of nitrogen?
Sir, I
Yes.
don't have the periodic table open right now.
No need to open the periodic table. I'm telling you that there is no charge on this compound. This is neutral. This is neutral. This is neutral. And just when we have solved the charges, this is -6 and this is +1. If I solve, this should be -5. +1 and -6. Just write it down on your calculator. So you will see the answer would be -5. Since there is no charge on this compound, so the nitrogen should be +5, so that they may cancel each other to become 0. Are you getting my point? Are you getting my point? Yes or no?
Yes.
So this is the charge for nitrogen over here, that is +5. Can you tell me the charge of nitrogen over here, since the oxygen is -2? And you know there is no charge on NO, this is neutral. So to make it zero, what should be the charge on nitrogen? Can anyone tell me, please? This is very easy. To make it 0, since we know the charge of oxygen, that is -2, so what should be the charge for nitrogen, so that they may cancel each other to become 0?
+2.
Can you tell me? Exactly, this is +2. Exactly, this is +2. So nitrogen is changing from +5 to +2. This is the decrease in charge. This is the decrease in charge, and decrease in charges, reduction. So HNO3 is reduced. Yes, is that clear for all of you? Now this is better. I think so. Hopefully. Okay. So you are supposed to more and more practice. You're supposed to do more and more practice as much as you can. So inshallah, it would be helpful for you. Okay. Okay. We would be inshallah discussing oxidizing agent and reducing